Distribution of electrons in shells of an atom. First of all, whenever they give you an atom, they want you to distribute electrons in shells. So the number that is given to you is called atomic number. So they're going to give you a specific atomic number. So at your level, the examiner is not expecting from you to memorize or to know all the atomic number of any element is going to ask you. So every examiner is going to give you the atomic number. So the atomic number will be communicated in a question paper every time. So you don't have to stress, should I memorize all the atomic number? No, you don't need to memorize the atomic number. Every time the examiner is giving you, for example, is going to ask you to distribute electron in shells of an aluminium, for example, and which has an atomic number 11, for example. And then you know that the atomic number is 11, then you distribute 11 in different shells. So now how do you proceed to distribute? This is the formula. 2 times n to the power 2. So n is the number of shell. So for example, if we are on shell 1, let me write shell 1. So how does this formula become? This formula becomes 2 times 1. Why? Because our n becomes 1 because we're on shell 1. Remember we said n is the number of shells. So since we're on shell 1, the formula becomes 2 times 1 to the power 2. And the answer is 2. So automatically we know that in shell 1, the atom is going to have 2 electrons. Shell 1, 2 electrons. I'm going to do this notation for electrons. I'm going to write an E and then put a negative sign on top just to show you that these are electrons. So what if you want to, how many electrons go to shell 2? You still apply the same formula. Shell 2. Shell 2 is going to have 2 times 2 to the power 2. So if you do your calculations correctly, so shell 2 is going to have 8 electrons. And if the atomic number was even much larger, so you go, how many electrons would go to shell 3? So shell 3, the formula continues 2 times 3. Why? Because we're on shell 3. So 2 times 3 to the power 2. So shell 3 is going to have 18 electrons. And so on. You follow the formula. If you have to go to shell 4, you do the same thing. 2 times 4 to the power. So if we have to go, let's do the last time, shell 4. So if you have to go to shell 4, it is 2 times 4 to the power 2, which is 32. 2 to the power, that's 16. 16 by 2, that's 32 electrons. So shell 4 is going to have, and so on. Doesn't matter how many shells would an electron have. And we're going to draw, we're going to make a sketch of how these electrons will be distributed. But let me take an example. We're going to solve question papers and we're going to find some of these examples the way it is asked in a question paper. But I'm going to make a quick example just to give you an idea of what we're talking about. Let's say an atom has an atomic number, an element given to you has an atomic number 14. So atomic number, if an atomic number is 14, if an atomic number is 14, and they ask you to distribute 14 electrons in different shells, how would you do it? The examiner can ask you to show calculations, and this is what you're going to show. Everything we have done here, you just have to know how many shells this atom is going to have. With 14 electrons to distribute, how many shells do you think? Because we know that if you follow your calculations if we follow the same calculation, let's use this as our reference. So if we follow these calculations, we're gonna know that shell 1 is supposed to have 2 electrons according to our calculations that we've done here. So if we have 14 electrons to distribute and shell 1 already takes 2 electrons, so how many electrons we have left? So we're gonna 14 minus 2, right? So we're gonna have 12 electrons left. So we go shell 2. How many electrons does shell 2 requires? According to our formula, that's 8. So if we have 12 electrons left and you remove 8, sorry, let me first write shell 2, that's 8 electrons. Shell 2 takes 8 electrons. Now if we have 12 electrons left, from the 12 electrons that we had left, we assign 8 electrons for shell 2. So how many electrons do we have left? 4 electrons. So there is no need to continue with your calculations because shell 3 normally is supposed to get 18 electrons, but here we only have 4 electrons left. So there's no need to continue your calculation. All you have to do is just say shell 3 is going to have the left electrons. So shell 3 is going to have 4 electrons. Finish. You don't have to continue calculations. Automatically we assign the 4 electrons left to shell 3. So now if they ask you to make a drawing, so what do? This is how you make a drawing. I'm going to try to keep some space there. So I'm going to draw a circle. That's the nucleus. And I'm going to assign a positive charge because the nucleus is consisting of a proton and neutron. So proton don't have, neutron don't have any charge. So proton has positive charge. That is why the whole nucleus is going to have a positive charge. And the first shell comes there around the nucleus. So that's the first shell. How many electrons go to first shell? 2 electrons. I can just write my E there. E and E there. So that's my first shell with 2 electrons. Okay, shell 2. I'm gonna draw a circle, another circle there. That's my shell 2. And how many electrons go to shell 2? 8 electrons. So 8 electrons. We are solving this problem with 14 electrons. So out of the 2 we have left 12 left, and then from the formula shell 2 is going to take 8 electrons. So we're gonna, from the 12 we're going to remove 8 for shell 2. So we count 1, 2, 3, 4, 5, 6, 7, and 8. So we assign 8 for shell 2. And now at last, shell 3 is going to have the leftover. So that was 12. That was minus 8. 8 went to shell 2, and we had 4 left. And the 4 goes, we assign them straight to shell 3. You don't even have to think because that's what left. So 1, 2, 3, and 4. So you read your question carefully. The examiner sometimes asks you to just show the calculation. How many electrons will go to shell 1? How many electrons will go to shell 2? How many electrons will go to shell 3? Sometimes the examiner asks you to show calculation and draw a sketch. So you do both like this. Thank you. That was distribution of electrons in shells of an atom for you. Thank you. We continue with the next part.